All right, good morning, everybody. We have a little bit of an iteration for today's panel. So unfortunately, one of our panelists is out sick. Fortunately, we had Professor Lilo Pozzo as our moderator for the day, and she's actually who oversaw and ran our Entrepreneurship capstone program for many years and has been significantly involved with supporting undergraduates getting involved in entrepreneurial activities as undergraduates, as well as helping facilitate transition of technology out of their undergrad, master's, or PhD work into starting up a company. And Volha is a great example of that because she did this with Polydrop, the company that she helped start up from some of her capstone work when she was working, that was advised by Lilo. So for those of you who haven't had a chance to meet Professor Pozzo, she is actually a chemical engineering faculty, but currently serving as interim chair of material science and engineering. And she's been a fantastic mentor to me, but also I think to many faculty in the department, and has been highly engaged with undergraduates in research, as well as in these capstone experiences, particularly in thinking about converting into an entrepreneurial space. And then our other panelist for today is Volha, and she graduated in 2013 with a bachelor's in chemical engineering from the department. And then after graduation, actually took a concept that she and a couple of other members had been working on and started a company called Polydrop, which was really in the field of advanced materials and manufacturing. And so we're going to get a lot more from her about her background and her experience, and then we'll move into the question and answer period that we've done with every other panel we've had this quarter. But we're going to have it be a little bit more conversational today, and we'll get some of Professor Pozzo's insights on like what you as an undergraduate can do from the faculty perspective to really get engaged with this sort of space going forward, especially if it's one you either don't know a lot about or you want to get kind of hands-on experience with. So Volha, I'm going to hand it over to you if you don't mind giving us a bit of background on yourself, as much of your bio as you would prefer to share, and then we'll follow up with some questions. And actually, Lilo, if you don't mind, I might actually also ask you to do the same after Volha, just to kind of give your background and kind of what you've seen as your role, particularly in the entrepreneurial space, if that's all right too. All right, Volha, I'll hand it over to you.
Perfect. Thank you so much for inviting me. Great to meet you all. So I'm Volha. I am originally from Belarus, and I moved here for school. So back in 2010, I entered the University of Washington Chemical Engineering program, and I graduated in 2013. So in my junior year of school, I did co-op as a process engineer with Alcoa. And that's when I realized that I don't really want to work as a process engineer in a factory. And following year, we had this opportunity with the capstone project, where we would take an idea, particularly our idea was from Professor Pozzo's lab, and take it forward and see if we can develop a prototype and if we can be entrepreneurs for a year, basically. So it ended up being a great success. We developed a prototype, and our idea was basically developing conductive polymers and putting them into paints or resins or plastics and making them more conductive, which was mostly used for static charge dissipation. So we ended up taking the first place at the Environmental Innovation Challenge. I don't know if you know about Environmental Innovation Challenge at all, but that's like the program run by business school. And then I think second place at the business plan competition. And I had 4 job offers that year from different companies, but I ended up, I was very interested in basically the business side of things for Polydrop. And so I decided to take it forward. And one actually company, which is called, I think, Precision Cast Parts, I had an offer from them, and when I called them and I told them, like, look, I don't think I'm gonna take this job. I'm sorry, because I already accepted the offer. And they were very nice, and they told me that They will wait for a year until I explore my entrepreneurship journey, which was awesome. So this can happen to you as
Uh-oh, I think we lost her for a minute. Lilo, is that frozen on your end as well? Volha, can you hear us? All right, we might have lost her. We'll wait until she hopefully comes back. I'll see if I can send her a message.
Unfortunately, we had.
You're there. We lost you for a little bit of. We lost you
Okay.
for a couple, maybe about a minute of time. Can you hear us? Okay. Oh, I think that's freezing again. Lilo, do you want to? I'll message Volha and let her know that. Oh wait, you can't unmute yourself. I thought you were in there as. Okay, we'll get this. We'll get this sorted. Always a joy. You think after 5 other times I'd have this figured out by now. Okay, there
now
we
it
go.
works. Yeah. Sorry, I was trying to respond, but I was like, okay, I guess.
No, you're right. I just controlled blocked, muted everybody. I'll message Leah. Do you want to pick up on this program of what she was mentioning about the capstone, the environmental and health challenges? Because there's 2, right? There's innovation challenges for both, and then we'll see if we can get her to pick back up when she jumps back on.
Yeah, totally. This is one of the best, I think, activities that the students that participate in this program actually undergo. Because what you do is that you, like Volha was saying, essentially take your idea and you develop it first from a technical perspective, which obviously you use all your engineering, all your chemical engineering knowledge in that. But then you have to create a business plan, right? And pitch this idea as a way of actually making money. And that takes a completely different perspective. So the business school, in particularly the Berg Center for Entrepreneurship, which is part of the business school, runs these competitions that essentially help students it gives the students a platform to present their ideas to a completely different crowd. So these are not typically engineers, but more entrepreneurs themselves, or lawyers, or investors, just a very different crowd. And they have very different questions than they will ask you than what an engineer or a professor might actually have. So I'll let Volha continue to explain her perspective on the competitions. Volha, you disconnected for a bit, but I was explaining how valuable those competitions are because of the different perspective that they give to students. Like they usually get questions from lawyers and entrepreneurs and investors, which are very different perspectives than those from engineers. But you can carry on.
Yeah. So, and I guess after the competition, I took the company forward. I ran it for 5 years, raised about 2 million of government funding, angel investing, and strategic partnerships. And unfortunately, we ended up shutting it down. But as an experience for me, it was an amazing experience and growth personally. I ended up then working for Intellectual Ventures, where we had like a studio model of venture investing, where we would take patents, we would look into problems in the world, and we'll start companies out of patents that they had. So I did it for 3 years, and now I am at Creative Destruction Lab in Foster Business School, where we pair an incredible mentors from different industry, basically. I lead advanced manufacturing cohort right now, and we pair them with startups. They could be from university or could be from anywhere in the world.
Well, we've got a one actually follow-up question from an audience member. Since you mentioned the 2 million in funding that was raised, and that was government funding, where did that come from, and how did you get that? And similarly, I'd love to hear from both you and Lilo, where do these ideas come from? Like, how does an idea initiate, and then how does that kind of lead into actually thinking about a technology out of it? So maybe start with the following up on the government funding, where that comes from and how you got it.
So it was from National Science Foundation. So it's called a Small Business Innovation and Research, or SBIR, it's called. And that one is about 1.2 million, I think, altogether we received. And then we got angel funding and some strategic partnerships and sales. That was a combination of three, basically.
Awesome. And is that pretty common for most companies or ideas? Like, at what point did you start to engage with those funding mechanisms? Because you mentioned that this was something that grew out of your work during your degree at UW. Was that something you engaged with earlier? Was that something that came after the fact? How did that initiate?
Yeah. So small business funding, it's very well known for startups. Mostly for science-based startups, not like startups that any idea has, right? Like, and in NSF specifically, they focus on deep science, right? So, and Professor Pozzo was instrumental in helping us, like writing a proposal and helping with their funding. So basically, I think I just graduated and we applied that, like in 2 weeks, we applied for this NSF grant for Polyjob. And I think if it wouldn't be like, we didn't know how to write grants very well, but Professor Pozzo actually helped us to write it. And we were lucky to receive it. And I think it's like a very low chance of receiving it the first time. For the angel funding, it came from just a whole bunch of angels and developing relationships with them over time. And customer strategic partnerships, that was also later in the stages of a company, like in about 2 years or so, once we had a product ready. And NSF pays for idea to prototype to actual like scale up and product. So
awesome, thank you. we're gonna walk us back a little bit to picking up on the last point you just made about the idea itself. And maybe, Lilo, can you kind of give some insights into where these ideas come from? Are they student initiated? Are they faculty initiated? Is there some external or outside partner that might bring an idea to the table, and then a student group kind of forms around that idea? Can you kind of walk through that process?
Yeah, I'll definitely do that. I'll also make a point to say that even though that sounds like a lot of money, startups actually use a lot of money. So I saw Volha like really work freakingly hard to actually keep the company running. So I just want to emphasize that not to paint the picture to students that this is a super easy track, because there's always uncertainty in getting that funding. But even if you do get that funding, startups, especially technology startups, can be very expensive to run. So I know Volha made lots of sacrifices, personal sacrifices, to actually keep the operation running. For the idea question, this actually is something that is evolving. So I have to first admit, this is a little bit like therapy for me, because it definitely felt a little bit like a very challenging experience for me and for Volha to go through this. I was doing it for the first time with Volha. So she was actually the first student that I actually helped go through this process. And I was not an expert in the pathway. So I was learning along with her, and I'm sure I made tons of mistakes too. But at that time, the initial, I had ideas, I had technologies working in the lab. The easiest thing was to actually focus on those some of those technologies and actually launch that, and that's what we did with Polydrop and with Volha initially. Obviously, the students, took something that was very ill-conceived and they kind of pushed it forward. So they definitely added to what was an initial idea. But in future iterations, with running this capstone experience for students, I decided to actually move away from that. I wanted the students to actually own the ideas and start from scratch. So instead of actually postulating this is a technology or an idea, I actually started with a problem. I would actually say, or not even a problem. Sometimes I would actually just say, find a problem in this area. So I would give them kind of like constraints. I remember one year I told them, I want you to work on a food technology. And it's like, okay, whatever it is, just related to food, okay? I don't care. And then they would iterate, identifying, well, what are needs, right? What are people struggling with? How could we contribute, right? Like, and they were part of that ideation. And we would spend a good chunk of that first quarter. This is a year-long or 9 months, essentially academic year-long project. That first quarter, the students would spend the majority of the time trying to identify a good potential technological solution to a problem that people cared about. So they would actually start from something that identified need. And actually that, I think it's much more likely to be successful in a business sense, because if you start from technology, and we as faculty tend to be technology pushers, right. We're just interested in technology, we develop technology, and then we say, hey, you should use this because it's way better than anything else, rather than really taking a step back and finding like, okay, what are people really struggling with right now? What could we actually develop? So I like the approach of starting from a problem and letting the students really, really own the ideas. The other thing also that I realized later on is that this actually helped for students that were really interested in making like a career out of entrepreneurship. This gave them a lot more freedom, because if I didn't help conceive the idea and the students conceived the idea as part of the course, the students would own that idea and they didn't have to have any kind of IP delegation to the University of Washington. So that was actually quite important for the students that wanted to be completely independent of any financial commitments with the university. If it is an idea that starts from our labs, then because we are University of Washington employees, then the students actually would be tied to some of that intellectual property ownership that the university would have. So I thought that actually, if I hope to teach that class again when I get back to ChemE, and I think I would definitely take the approach of just starting with a problem statement rather than an idea.
Yeah. I think you bring up some great points that also could feel kind of intimidating. Volha, one of the questions that came in is, how do you even begin to learn or kind of refine an idea when you're coming at it without a ton of background in it? Or when you get, say, presented a problem and it's very open-ended, you sound very open-ended. So what's your process as a student working in a team? Can you kind of talk through the work that went in to taking the idea from idea stage to actually turning it into something that was like at product stage?
Yeah. So I think for us, as Professor Pozzo mentioned, it was a bit easier because the idea was already there, right? Like, but we still, like, I remember, like, I was like reading my first paper, scientific paper, and I was like, what is this? Like, it took me like maybe 2 days to go over and over and over again. But it gets easier over time, definitely, right? And then I think if you're genuinely curious, right? Like, you ask a lot of questions, you're not afraid to ask questions, and you're not afraid to learn. And that's what I think ChemE teaches you, is to actually, ask questions, and it puts you into this kind of like a logical problem-solving mind. So I think what we did actually very well is we were very focused. So for example, in early stages, we just had an idea, and then we just had to develop a prototype, right? And we came up with an idea that we're gonna like put our product into paint, and it will like light a light bulb, right? Like, so in between, because it was conductive, so we would put like basically just put two things in between, and it lights a light bulb, right? And we were very focused on this. Yes, we put a lot of time and effort into it, but we did that prototype, right? Like, and that's why I think was partially why we won at the Environmental Innovation Challenge. A lot of late nights, right? Like, because your senior year, I think is still challenging, right? But we would just do it after work. I mean, you've spent all your days in Benson Hall anyways, like your senior year. So it was still challenging, but I think we did great in terms of like focusing and taking that. And once we had a prototype, we had a little bit of data. We could show the data that we are getting somewhere, right? And we started showing this data like to customers. And one of our first customers was actually here in Seattle, called company called GM Nameplate. They got acquired, I think, by other, like, I don't know, some big giant, but at that time they were GM Nameplate, and they actually, like, I think they called us or we reached out to them, and we started working with them right away. And we were we would go to their facility, we would learn everything, the process, how they do things. They were making a UV light, basically like a faceplates for like microwaves, right? Like, and other things, right? And they needed like anti-static material in their UV light paint, so, or faceplates. And so basically we would develop relationship with them. But what we did is like, we learned a lot, right? Like on the floor there, and we would bring them samples, right? And we would get feedback, and we would go iterate, bring samples again. I think we did it like maybe 10 times with them, right? So, and that's very important. And I think that was like, when I saw the first customer, like potential customer, right? Like, that was like, wow, like this product could be used, right? Like anywhere, right? And I was thinking, I mean, it also gets like a lot of like excitement, right? In you. Yeah. Definitely. And then so you want to work even harder and harder, right? Like, so there were a lot of unknowns, definitely, but I think you just have to be comfortable with taking the risk, right? Like, and learn how to deal with uncertainty, right? And Professor Pozzo was like really good at like, okay, we're getting this couple of features, which is conductivity and dispersibility, and then we're gonna like look at others, right? Like, so we would always, you know, look into first focusing on two and then getting others to work once we learn like more customer features. So.
Yeah, I appreciate also that, you know, the moment when it becomes really real is when you actually have that interaction with your customer and you see where the potential impact and the need for something is. And I think that ties back in nicely to what Lilo mentioned before about, you know, really thinking about what's the problem on hand that needs a solution to it, and who's going to be the customer or the market base to really, you know, best use whatever your idea turned into a product is going to be. You mentioned that you know, you thought the ChemE training was very valuable to this. So I'll put this question to both of you, because for those who don't know, Professor Pozzo has a bachelor's degree in chemical engineering and a PhD in chemical engineering. And Volha got her bachelor's degree in chemical engineering. So can you both speak to why ChemE and why ChemE was of interest to you, and if this kind of role of being involved with entrepreneurial type of activities was something you were thinking about early on, or was something that you kind of became exposed to, Volha, while you were in your undergrad training? And Lilo, maybe, you know, as part of your faculty career, was this something that was always of interest to you, or is it something you kind of saw opportunity to do as a faculty? So Volha, do you want to start? Maybe talk about your why ChemE.
Yeah. I think I was always like fascinated by chemistry, right? Chemistry and math, that was like good for me, right? And so I thought chemical engineering was a great fit, definitely. And I already entered school in Belarus. I moved here like kind of like halfway through it. So, and I think what I did not know, ChemE is pretty challenging. It was challenging for me at University of Washington. I think because the way you like study here, and I don't know if there are any immigrants in the room, but like it was very different style than what we did. We did like oral exams in Belarus, so I was just not prepared for some of this. So, but I think what was great in ChemE and what I learned a lot is group work, right? So a lot of classes have, so you work as a team. It's something that I value the most, because that's a skill set that you will use all your life at any company, anywhere in the world, right? And learning how to communicate effectively with each other, learning how to motivate each other, et cetera, right? So that was like valuable for me. And I think also the way some classes are designed is like, for example, some of their I think operations, like the classes where you have hands-on like experience, and you have to think about the problem and solve it certain way, basically, right? So this skill, like logical thinking, and how do you define the problem and how do you solve it, this again is used on like in all of my jobs, right? So, and I think when I say chemical engineering to anyone, even in business field, they're like automatically, okay, so she can figure out like really tough problems, right? Like she understands how things work, right? Because I'm mostly now working business, right? But at the same time, I can dig in like deeply into like really, really hard things, and I'm not afraid to that, and I'm able to work very well in a team. So that's like the skills that you probably will use the most.
Yeah, I appreciate that. I think, and it emphasizes too, kind of the benefit of, particularly in those senior classes, like our design and lab courses, where questions are more open-ended, there is more uncertainty to them, and you have to do more, upfront work to kind of understand what the boundary conditions are and what the scope of the problem is. Also, just will highlight, I appreciate that, like most of the time, I feel like we probably have this experience where when we say we're chemical engineers, it either shuts down the conversation because people are like, I have no idea how to talk about that. Or people are like, wow, that's a really hard degree. You could probably do anything. You're really smart. And so I appreciate that. I can relate to that as well. Lilo, what about you? Because you did multiple degrees in ChemE. What kind of inspired you? I'm putting you on the spot here. I know that's not what you signed up for this morning.
No, this is totally
what got
fine.
you into chemical engineering? And then how did you get, because you have led our entrepreneurial design capstone for many years. How did that become an aspect of kind of your role as a faculty?
Okay. So there's a lot of questions. One,
I know.
how did I ended up at ChemE? I really liked chemistry, and it was a great chemistry teacher. And I thought I'd rather go into engineering than chemistry. So I went into chemical engineering. At the time, entrepreneurship was absolutely not in the horizon for anyone. Like you go into chemical engineering, you were thinking you're going to work for a petrochemical, some big plant. In fact, all of my internships were in companies like this. I only really started to venture into entrepreneurship actually with Volha for the first time through this course. And I think that it was at a time where the job market for chemical engineers was actually changing drastically. So a lot of our students now are no longer going into petrochemical plants. They're actually going into high technology fields, usually involving much smaller companies, very dynamic companies. So now our students are frequently going into biotech, maybe startups, biotech. There's another student that I helped start his company called Membryon, and they've actually recruited several of our undergrad and graduate students. And it's a relatively small startup company still. It's growing rapidly, but it's still relatively small. So this is relatively new. And in fact, teaching about this in our courses is really, really new. So I think that ChemE at the University of Washington has had kind of like a leading role. And actually, I have to say, Dan Schwartz was the first person to envision this as a perspective that we should follow. So he taught the first version of the entrepreneurial design option, and I continued teaching it for many years afterwards. I want to address also the question about what makes ChemEs particularly good. I think that's essentially entrepreneurship and startup, that I think other engineers, as I learn more about the disciplines, maybe don't get this benefit. So from the beginning, when you are in chemical engineering, we teach you how to think in systems. So what is a system? A system is a series of steps and series of components that work together. And the key here is that, right, when you take your first ChemE class, which would be materials and energy balances, you already are ingrained, hey, everything is a system. And the mentality is, if you tweak things here, it doesn't just stay there. It actually propagates all over the plant, and it has major implications everywhere else. So from the beginning, this is kind of like in your blood. It's integrated into how you actually think. And even though you might be managing even a software business, or it actually helps a lot in terms of thinking, you know what, if I change the product price, it's going to have these major implications elsewhere. Or if I change the way I market it, or if I change my business strategy, or if I change where I'm getting this particular raw material, or like, we think in systems levels, and that is not something that is universal across engineering. Some engineers definitely have this systems level thinking too, but not all. And I think chemical engineers definitely have it. And I think it's particularly valuable when looking at getting into this area of entrepreneurship, because everything is interconnected. Anything that you change, anything that about your business strategy or your technology has huge implications.
Yeah, I think this is a great point of particularly coming from the perspective that you're currently chairing another engineering department. And so you get to see how this plays out on a day-to-day basis in terms of seeing how different engineers approach different problems. Volha, that actually brings me back to another question that came in, which is, who did you work with in this team? Were they all chemical engineers? Did you interface, like, in terms of the initial idea development and kind of and getting the formation of Polydrop actually taking place? Like, who were your team members and what degree backgrounds did they come from?
We were all in ChemE, so 5 of us were in ChemE, and so we formed the company later. But in our capstone project, there was like 5 ChemE students, so we didn't get like too many for business plan competition. It ended up only being 2 of us, and we actually were paired with an MBA student as well. Okay. So that was a great also opportunity for us to learn and to work with her, because I started going to like an evening like classes that you can just like drop in and attend, and that was like a completely different world to me. I was like, what? Like this is how people think also, right? Like, so and I think that was also like a great benefit to us, because we got to work with her and we got to see how business people think of things in numbers more than in like, basically solving the problem, right? Like, so that was how we structured it in the beginning, right?
And Lilo, was that your experience with some of the other teams that you facilitated? Were they mostly ChemEs because that was the focus of the entrepreneurial program, or did you see places where it made sense to bring in other degree disciplines depending on what the potential product or idea was?
Yeah, definitely. Okay. Most of the teams, actually all of the teams that I advised, were either full ChemEs or ChemEs with business school integration, just like Volha was saying. Now, if I did it again, I would definitely try and change that a little bit. Now, after that, at the time, the University College of Engineering didn't yet have this interdisciplinary capstone program, which we currently have. Now, our interdisciplinary capstone right now is primarily industry sponsored. So it's actually driven by problems coming from industry. That's different than the entrepreneurial design experience, which is kind of like from the ground up, right? Like you start from scratch. There's nothing, no money, you start from the beginning. But I do think that there is something to be said about bringing students with very different skills to work on a combined project. And I think all of the projects that the students tackled would have benefited from having interdisciplinary students represented, because they all bring different way of thinking, different how to make that a part of a successful course experience would need to be discussed, because again, I don't think that right now we have these 2 things, right? The entrepreneurial capstone that is in ChemE, and then we have the interdisciplinary capstone that is driven by industry from the college. It would be definitely great to bring something new that actually allows for interdisciplinary teams to work on entrepreneurial activities. I did try it once. One year we did do it with one team that combined aerospace and ChemE students, and they were actually creating these drones that were going to fight fires in the forest. So the aerospace students were developing drones, the flight controllers and everything. And the chemies were figuring out, okay, how much firefighting power can we put into the lightest weight material as possible, right? So that the drone could actually take it very far. So that was the one time I had actually a mixed team of engineers.
That sounds like a very cool project as well. That brings me to one of the other questions that was submitted, which is, and Volha, if you want to take this to start with, how did, kind of diving deeper into, how did your degree specifically help prepare you or play into your work in managing a team or directing a business? What were the kind of correlations between what you did in your coursework and bringing those skills into the actual job of leading a team and managing a business?
I think working in teams, right? Like definitely were helping. I think I was really bad at like managing the team initially, just because I didn't know what to do, how to do it, etc. But I think ability to learn, right, fast, and that's something that I think ChemE taught us pretty well, right? And like Professor Pozzo was saying, like, you learn and you introduce a system, right? Like you learn differently, right? But at the same time, you learn fast, right? So I think what it taught me is basically I can solve any problem. Sometimes I just need a little bit of time. I'm allowed to make mistakes, and I can always, reiterate and get it again done, right? So this was like me doing it by myself the first time. I mean, just like doing it the first time. And of course, I didn't know many things, but I was ready to take any problem and solve it, basically, right? Like, so, and some of them were successful and some of them were not. So it was good.
I appreciate you bringing up this part of, I think, what most people associate with, failures, and sometimes they can teach us something, and other times maybe you just recognize that it's a failure and you kind of move on. It kind of brings up to a couple of points you've both mentioned, which is sort of the uncertainty in the process and the risk that you're taking in the process. How do you assess risk, and how do you handle that uncertainty, particularly when you're especially if you're kind of coming at this as you've graduated, you've got your degree, and this is the first thing that you're kind of pushing for and pursuing?
I think willingness to take risk, right? I think in your 20s, you are more likely to take risk than when you're in your 30s or 40s, just because, I don't know, age, life, right? Like, et cetera, right? And uncertainty I was never afraid of uncertainty. I think what we did well was handling it, like, was always fine. And I think each person has to learn how to like deal with it, basically, like, and some people deal with it differently, right? Like some people basically save enough money, for example, right? And then go and do startup or entrepreneurial experience. So they actually feel better that they have, stability, right? Like they have something that they have saved, right? Like some people like me, I was ready to take it on and work. At some point, I think we had like 3 or 4 months without money or something. I was working for Uber, like put my house on Airbnb, like did all of this like crazy things. And I was comfortable with it, right? Like I knew like what I was working for, right? And I knew what our final goal is, right? I think in the times of uncertainty, you just focus on what you can control. And that's something that I learned through this experience, is like you focus on what you can control, and what's out of your control, you just let it go, right? Like, because if you're gonna like overthink everything, then things might not happen, et cetera, right? Like, so I don't look in the future. I just, every day in my life, I look, okay, there is uncertainty here. What can I control today? What can I do today to that depends on me, right? Everything else is out of my control, basically. So that's what I learned, definitely.
Yeah, and I appreciate that perspective too, because it's not saying that you won't ever face uncertainty again or have risk, that it could be somewhat of a constant, and kind of learning how to navigate it and manage it is a big part of kind of applying those skills. I want to connect that back to a point that many of you might have heard Professor Pozzo make earlier. And if you don't know, she's been a faculty for, a reasonable number of years. She would be considered a senior faculty and an incredibly successful faculty, but you might have heard her mention that she did not know a lot of things when she was starting this process of helping facilitate Polydrop getting started. So Lilo, do you mind I think this is such an important point that we hear frequently from our alumni, but I hope resonates with students early on, which is that even when you're established in a career, you run into a lot of things that you don't know, or introduce kind of that uncertainty or new challenges to you.
Yeah.
Can you talk a little bit about your process for navigating when that happens?
Yeah, I want to acknowledge first the first experience I had venturing into entrepreneurship was with Volha. So like I said, I think fair to say we were both ignorant and we jumped into it, and we both probably made a ton of mistakes going through the process. But it also was critical to find what my role was best, right? I dove in, and actually I stuck in with the company. I tried to help as much as I could, but I was still obviously primarily being an academic. And I was trying to figure out, okay, I knew of other faculty that had started their own companies, and what was my goal, right? What did I want to do with this role, and how did I, and I ended up deciding that actually what made me happiest was actually to help students identify if they wanted to be entrepreneurs and to help them. But I did not myself want to become an entrepreneur, not just yet. So I think that the pressures of my job were too high to be able to juggle both things. And I generally am very curious. And I also thought that if I had actually started my own company and really, which many faculty do, and decided to put all my effort into that, it would be too constraining. I actually really like the idea of really working on multiple different technologies and helping students kind of continue launching this. It just fulfilled me a little bit more. So I decided actually that what my comfort level and risk was actually much more compatible with just helping students that were driven, like Volha and others, to really push forward. Now, I have to say, the majority of the students that went through these courses did not go and become entrepreneurs themselves. I actually helped 2 students, Volha and one more, launch their own companies. Many of them, of the others, did end up working for startups, so they did like the ecosystems, but they didn't necessarily start their own companies. They became comfortable enough, and they liked the dynamic aspect of this. But the majority of them do not start their own companies because it is a really, really challenging and risky thing to do. So it is actually something that requires the right attitude. And I have to say that, Volha has a lot more guts than I do, because I remember when I first started seeing accumulated bills of lawyers from all and it's in the several tens of thousands of dollars. And I'm like, what? And I didn't know. I was like, are we going to have to pay this? How is this going to work? And I was super concerned. I had kids in school and so on. I'm like, how is this going to work? And later on, you find out, right? Realize that, if the business folds, then lawyers don't get paid. And there's a lot of things that actually, but before, right? Finding out, it was really nerve-wracking. And I think that you don't know what you don't know. So there are all these things that you're kind of pushed to do when you choose this that really definitely takes a little bit of guts. Having said that, I do think that the majority of the students that went through this experience really appreciated it because it helped them to think differently. And many of them did end up having very fulfilling and rewarding careers in entrepreneurial ecosystems. whether they started their companies or not, many of them did end up working in startups. And even now, like Volha said, Polydrop ended up closing, but she's still driving entrepreneurship for students. And before that, also with Intellectual Ventures, which for those that might not know, it's also like one of the major investors, right, in entrepreneurial ideas here in Seattle. So I do think it still provides value, but I ended up becoming a lot smarter about like what was my best role, right? And I think it is actually helping students that are motivated either explore these ideas and this part of themselves, or launch if they're really how to say brave enough, right, to launch their own ideas.
Yeah, I would also echo Volha, like you're describing your experience. I'm just sitting here like in awe about how brave and courageous that seems, but also just like how, what skill that takes to invest in that and sustain that. So I just, congratulate you for seeing that through as well. I think it's really awesome to see, because to me it sounds terrifying. Similar to what Lilo was mentioning, like I have interest in doing things that impact human health, but I'm not myself interested in starting the companies up. So I'm all in support of students doing that. But I think figuring out that role is, I think, a critical component. But I think also, Lilo, a point that you mentioned about even if you have exposure to thinking about starting up a company and you don't end up starting up your own company because it is incredibly difficult and challenging, there's also that opportunity to translate those skills into understanding what a startup space looks like and what, the pace and intensity and potential risk of working with a new or, early stage company looks like as well. So I think that's a great point for students to kind of internalize too. We have about 2 minutes left. So I want to ask one remaining question for y'all to give your input to our students. What could they do now? What can you do as an undergraduate now to either explore this space or to get a sense of what that world is like, or to start building skills if that's something that they're interested in? And Volha, if you wouldn't mind taking that first response.
Yeah. So I think explore as much as you can on campus, right? That's an opportunity you have while studying at UW. I think I worked through my first 2 years just to pay for school. I wouldn't do it again. I would rather take loans or something and explore more, because that's the only opportunity I had, right? And I think go do internship or co-op, like I did 6 months co-op, because that will give you a perspective on like what is the real like thing is, and do you like it or not? Because I think I wouldn't end up in entrepreneurial journey if I wouldn't have worked for Alcoa for 6 months and realized that, hey, this is not something that I really am enjoying, right? Like, so, and take experiences, right? Like be open to any experiences. I think that's the most important part too.
Awesome, thank you. And Volha mentioned getting engaged with campus opportunities. For everybody on these, if you've seen the post after these panels, we'll summarize many of those opportunities and link to them so that you can explore them yourself. Lilo, do you have any final thoughts on ways to get
I would just encourage students to, while we revive, right, like many of these these capstone projects, entrepreneurial capstone projects, there are great opportunities within the Berg Center and with creative destruction. I'm sure there are some that students should be exploring. There are teams that now, whether they're part of a course or not, that form just organically, and they're always looking for people. I don't know. I know that back then there was a matchmaking process that would take place before these competitions. So students might actually look into participating. I cannot really speak highly enough of these competitions as a learning experience. You get a completely orthogonal series of advice that you do not get from faculty or professors because it's essentially coming from completely different perspectives. So I think that, trying to engage in those. And then there are actually minors and options and courses that you can take, choose to take from the Foster School and from the Berg Center. If you have enough time in your time schedule that enables you to complete these minors, then that's another great opportunity. But obviously, ChemE is very intense, so maybe you do, maybe you don't have credits that you can actually engage in.
Awesome, thank you. We will definitely make sure for all students who are getting these reflection questions afterwards to post, summarize what many of the opportunities that Volha and Professor Pozzo pointed out, and then also just a reminder that Dave and Nicole and I are here to help facilitate you figuring out how to integrate these types of minors or experiences into your ChemE curricula. So it is an intense curricula, but we can certainly help figure out where that might slot in well for you. If we can, we'll get a round of applause, at least from the in-person people, but if we can give a round of applause and a thank you to Volha and Professor Pozzo for taking time today to join us. I don't know how much you're going to hear this, but we'll also get the online emoji response. Thank you, everybody, for attending.
Feel free to reach out if you have any questions.
Yeah,
I'm happy to take a 30-minute call to talk to you if you want to hear more, or if you're struggling to make any decisions or anything like this. So feel free to reach out.
Yeah, and I'll put that note in our reflection just in case anybody wants to help with that connection as well. Thank you all for attending, and stay tuned for the reflection question.